Hi and welcome back to the shop. In this video we will try to make some repairs for the tailstock of my Emco lathe. It's a V10P. The P is meant for that it's a power cross feed lathe, but it has some problems with the tailstock. The locking bolt, what is called tailstock lock to lock the quill, is stuck and don't work, or it works but it will not release again. And I think they have tried to repair it before, because when I put my drill chuck in, it actually has to go out over 5 centimeters. It's a little over 2 inches for it to lock. I don't know if you can see there's graduations on here, and we are now at 52 millimeters, and this is 50 millimeters, and now it's releasing here, which means I only have 3 centimeters, or a little over an inch travel left for drilling. And I think the repair is made in here, and they have put in a threaded rod too long to, so we will actually try to measure and then shorten the threaded rod. I have a little more room here. So we need to go a little forward and measure. There's 65.2 millimeters. Actually, I have a short taper center, no tang on this one. I will put that in and see when it releases, and I can see how much I can shorten it and it still pops out. I could of course put a spacer in the back of this one, but I think I will try make it so the short tapers will pop out and I can get a little more travel out of it. So we try again. This is 53.19. You can see that. I will write it down. And then we will close it all up. And another problem with this color with the graduations is not turning. It can turn, but it doesn't turn with the handle, so maybe I need a new shaft, or maybe I can modify this. Time will tell. I don't try to take it apart before. I only had the quill out to check if it was okay. It's a little worn in the back end because they have turned it too long out, and the little key in here is dragged out of the back end, and there's some shatter marks. I will show that when I get it out. Sorry. This is all the way back. This is 19.9.8 millimeters. And this means I can get 43 millimeters more travel for my drilling operation by shortening the threaded rod inside. And I will take it apart and put the parts on the bench. I don't think it's anything special. It's a lock nut in here, and I hope I can take it all out in the front when I take this off, because it's meant to pressure this way, and I think there is some spacer or something to hold it inside here, but time will tell. But I will take it apart off camera, and then I'll be back. As you see, I cut the tailstock apart, and I found the problem, both of them. I will zoom in on this shaft. As you see, there is welded a piece on in a taper form, and it looks like it's welded and ground on a normal bench grinder, and that's not very good, but I can part it off and make the travel right again. And this one, the lock is damaged in the bottom. There is a recess for a hex bolt that's going all the way through, but it's, when I tighten it, it's the this one is turning and locking in the bore, and it was very, very tight, and I had to pull it out by using the threads and a nut, and put some spacers in between and drag it out of the hole. You can actually see the end here, that it's mushroomed out, and it have a big burr right there, and I don't know if it is broken or what, but there's nothing, no pin or anything holding the bottom one, and I think I will make a one-piece system with the milled out pocket, what it's called when it's round the key, and we can just lift this and it will lock. Instead, I also found the quill when I got it out. I don't know, hard to see. There you can see this step. The upper part here is made with an angle grinder. There is very clearly grinding marks in here, and it's not very good. So I think I will chuck this up and mill a new keyway. And there is a pin in here, also look very homemade, very sloppy in the hole, and it is just a tap on the end of a bolt. And you can hope it's in the frame. Yes, you see how much slop that is in here, and I will of course make a new one that fits this keyway when I mill it out. We haven't measured it yet, but this cannot be good. So I think we'll try that. The quill fits nice in the hole, no slop or anything, and it looks original. I think it's only destroyed right here, and I think we can fix that. I don't know if it's necessary or anything, but just cleaning it up, I think that would be better. But let's see when we get to that part. I will start by parting this one off, then I can put my new parting blade to use and see if it works nice. And there simply is the axle here, and then there's a thrust bearing. Maybe that's an add-on, because there is a relief down there in the axle, and the inner ring from the bearing actually floats around in there and fits the shaft up here. So I don't know what's going on, but it will work. The quill centers it up in the hole, so it just pushes out. I can't see a problem with that, and the thrust bearing is a nice feature, even if it's not original. So first project, parting this one off, and then we will make a new lock, a one-piece part. I saw it in another YouTube video. I think it was Double Boost John Mills that made a dividing head, where he made this system, and he only made a one part, and I see the idea in this, and it just lifts, and when you loosen it, it floats, and the quill moves freely. I don't think I can make this so that it don't get stuck, because even if I turn it down and it fits the hole again, even when I tighten the handle here, it will try to rotate this bottom one, and this one could actually fit like this, and I don't think that's a good idea, and I need to brace or weld this in. I will try to show this. I don't know if you can see the round hole is not a round hole, and we have a little play here in this one, and the hex down here is totally destroyed, so that's a new one. One piece threaded shaft on, and then maybe I can use the original handle and make a lift washer or something for it. I don't know yet, but I will put the gullet chuck on and put the shaft in, and let's get it parted off. And let's see where we are. I just tried out my new parting blade, and I cannot go down to center height. This is a little wider than this one, and I measured it before I ordered it, but I don't know if he shipped the wrong one, or I have to find out. I have to use the old one, and that will go. I will just part it off there, and it's 43 millimeters down on the shaft. Actually there's a little thread here, but I will give it what it can take, so I get as much travel as I can. And now we will just chamfer it slightly, and I lock my table down here, so slide, so that's nice. I'm just chamfering until it's totally round, no threads, so it get a stronger surface, and if it mushrooms a little, it will not tear out and destroy the threads. And now it is my plan. That's much better. I think I could feel some little bump, or maybe just bad finish from the parting tool. But now it's nice. And the one very nice thing about the college chuck is that you can chuck on the threads of a thing like this without damaging anything. Get a good hole, part it off, and it runs through. If you try it clamping on the threads with a normal tree of audio, you will destroy the thing. Of course you can put aluminium or rounds or something in between, but this is the finished product in the right length, so make sure we can use some more travel. I found a piece of round stock and I measured the old lock and it is 15 millimeters. This is 20 millimeters, so we will just turn it down from 20 to 15, and then we will start by making the new lock. Let's see, now we should be within 800 over and we are warm. So, a little bigger in the outer end. Let's just now it's almost cool and it's 15 millimeters. I just stroke the file a little more on it when it's cooled down, and now it's 3/1000 of a millimeter from 15, and it makes us about 200ths of a millimeter, a little under 1/1000th of an inch clearance in the hole. Now I'll just polish it with some 400 grits. And a little Scotch Brite. And this, I think this finish will do the job. Let me try to zoom in and see if you can see the finish. But we need it nice because of the sliding fit in the hole, so we don't want turned rough finish. But this is okay. Now for the test. We will just put the tailstock on. Just happy it isn't Adam Booth's Monarch. And I think I have to eat a little more and work out a little more, but this is nice. Don't know. You can see I'm wiggling it now. It's no play. Nice. Now we'll just turn the end down 17 millimeters of threads, and I will go a little bigger. The other was 6 millimeter threads, and I will go for 10 millimeter and then make a new handle. Now we will just part a little groove in to the threads to end up in. Then for the threading, I just changed out the insert. It looked like it had a hard life, so let's try this one. I think maybe the shaft was a little too thick. Normally I try 1/10 of a millimeter under. This was only 7/700 of a millimeter under. It looks like it formed it in the top. No problem. Let's see if it worked. Yes. That's nice. And now we will just part it off, and then it is ready for we can mill the slot or the round. And now for the facing the little dimple off the end and a little chamfer, and then the turning work is finished. And zoom out. This is the finished plank. The old one. And now we only need to mill a recessed area here. I think this looks a little more sturdy, and actually it feels a lot heavier. I don't know if this is some cast Indian aluminium thing or what, but I think it turned out very nice. And now I've got the little lock set up in the middle, and of course I shouldn't have parted it off, and I know you're all screaming at me, but too late. Now it's a little work holding challenge, and I managed to get 32 millimeters between the V blocks, and I need a 30mm radius, 30mm diameter to make the recess. There's only one conclusion: don't do as I do, but do as I tell you. If I had the long bar on, I could have clamped it in the vise and let this part stick out and just milled it. But I hope this will work, or else I have to try again. So I will get a milling cutter in here and relieve some of the material, and then we will take the boring head. Maybe we will take the boring head from the start. I just have to think about that. I dialed the boring bar in with this block and just turned it around and fed the edge and the cutter a line on the back, and then I turned it around and measured it until it said 30mm diameter and locked the boring head down. I know this is not the most accurate way, but I think it will do the job. You could of course take a test and clamp the block down and then make a little scratch and measure it, but I think we are good. I can have a little clearance in this without getting into any trouble, so now I just need to see if it clears the V blocks, and then we're ready to cut. Now I centered it up between the two lines. I put the part down in the hole and marked it with a Sharpie, and I know I can't be too high, so I moved it on purpose 1/4 millimeter longer down, because this was bottomed out in the hole. I have a few millimeters clearance in the top, so it will be nice. I will try to take a cut and let's see how we do. That's it. Actually the finish is surprisingly good. I got a new mill The other one was just scrapped, and I argued with them 10 weeks on email, and they took it back finally, and I got a Bernardo now, and this one cut couldn't have been done on my Holzmann. So now it's just taking it out and testing it, and look, if fingers crossed that it will fit, I can show the finish. Not bad, not perfect, but I will give it a little deburring with some emery cloth, and then I will test fit it. And there we have the finished product, as you can see. I'm sorry for the light, but I had to be very accurate, or else I couldn't get the shot for you. It fits, no play, and it's down in there, and you can see if we rotate it, you can see it. And when it's now, it fits very good.